So let me ask you a question. It's a huge one we almost never stop to think about. What is life? Today, we're going to look for the answer, but not in a biology textbook. Nope, we're going to look for it in the fundamental laws of physics itself.
All right, let's just get right into it. The question. It seems so simple, right? What is life? You know it when you see it, but as you'll see, trying to actually pin down a solid definition is one of the toughest puzzles in all of science.
So, to kick things off, let's explore why it's such a massive puzzle. We're going to take all the usual definitions we learn in school, and I'll show you how, with just a little bit of pressure, they start to completely crumble.
Okay, check this out. This one just messes with your head right away. On the left, we've got a rabbit. No question, it's alive. On the right, a flame. Obviously, not alive. But wait a second. Look at what they both do. They both grow. They both use energy. They can both move, and they both react to their environment. All of a sudden, that simple checklist for what makes something alive starts to look, well, pretty shaky.
And you know, this problem just gets worse the more you dig. For every single rule you try to set for life, there's always some annoying exception. You say, okay, life has to move. Really? What about a tree? You say it has to reproduce. Well, what about mules? They're definitely alive, but they can't have babies. Complexity, that's it. Okay, but have you ever seen a snowflake up close? It's one of the most beautiful, complex, ordered things in nature, and nobody's calling a snowflake alive. It kind of feels like we're hitting a wall here.
So, since our biological checklist is failing us, we need a totally new way to look at this. What if the answer isn't a list of things that life does? What if life is actually a consequence of how the entire universe works? To figure this out, we've got to turn to a really deep fundamental law of physics.
And that brings us to this big idea, entropy. The easiest way to think about it is just as a measurement of disorder or randomness or chaos. And the second law of thermodynamics, which is one of the most solid rules of reality we have, says that in any closed system, like, our entire universe, the total amount of chaos can only go up over time. Things get messier, they fall apart, they don't just magically put themselves together.
To make this really, really simple, just picture a state of low entropy. In other words, high order, like this perfect stack of bricks. It's organized, it's structured, it took energy and effort to build it like that.
Now, what happens if you just leave that pile alone for a long, long time, or you just give it a little push? Of course, it falls down into a random, scattered mess. This is a state of high entropy. This is the default setting for the universe. It's the one-way street everything is on, from order to chaos.
And this is where life makes its grand entrance. Because if the whole universe is on a one-way trip to total chaos, then life is this bizarre, beautiful, and temporary rebellion that's actively driving in the opposite direction.
So, how does it pull this off? Well, living things are basically these incredible little machines designed to create and maintain order. First, they grab energy from the world around them, from food or sunlight. Then, they use that energy to build these unbelievably complex and organized things, like cells and organs. And finally, they are working non-stop, 24/7, to repair and maintain that pattern against the constant pull of decay.
And the amount of work this takes, it's just staggering. 330 billion. That's roughly how many cells your body creates from scratch every single day, just to keep the whole system from falling apart. It is a constant, epic, and almost totally invisible war that you are waging against the chaos of the universe.
Okay, but wait a minute. If the second law of thermodynamics is a fundamental rule that chaos must always increase, how can life even exist? Is life somehow breaking the law? Well, no, not at all. And the real answer tells us something profound about what we are.
Think of it like a cosmic balance sheet. Inside a living thing, say inside you, order is being created, so your local entropy goes down. You're building this tiny, temporary island of structure, but you have to pay for it. To do this, you eat food and you release waste and heat, and that process pumps way, way more disorder, way more entropy out into the universe around you. So we're essentially paying for our own little pocket of order by making the universe as a whole an even messier place.
So here it is, the main takeaway. Life doesn't break the second law of thermodynamics. It is a stunning consequence of it. It's like a cosmic loophole. Life is a process that builds and maintains its own little island of order by making the chaotic ocean around it even stormier.
Now, thinking about life this way doesn't just solve some old science puzzle. It can totally reframe how we think about ourselves, about what it actually means to be alive. This gets personal.
I want you to really think about this for a second. Scientists estimate that pretty much every single atom in your body is replaced over the course of about 7 years. The actual physical you from 7 years ago, it's gone. The person you are right now is a brand new collection of atoms, all arranged in the same incredible, persistent pattern. You're not a static thing. You are a pattern that matter and energy are just flowing through.
And that leads to this just awe-inspiring thought. You are not your atoms. They're just borrowing a spot for a little while. You are the beautiful, intricate pattern that those atoms create for one brief, shining moment in time. You're the song, not the instrument.
So let's wrap this all up. What is life with this new physics perspective? Well, it's not a thing, it's a process. It's a temporary little island of order floating in a universe that's always moving towards chaos. It's this beautiful rebellion that, strangely enough, perfectly follows the universe's deepest rule. And you are a pattern that holds itself together for just a little while as the world flows through you.
And that kind of leaves us with one last big question. If we understand that we're not these permanent objects, but these fleeting, beautiful miracles of order, it really makes you think about how precious this whole thing is. It begs the question that only you can answer for yourself. If this is what we are, how do we make it count?